roof. The people that are up there, that's the roof?
Yeah, that's the roof.
Okay.
Hi. So just state who you are, where we are, and then I'm going to ask you one question.
Okay, my name is Matt. I'm one of the guides here at Griffith Observatory. I'm in the Eclipse Alcove, which is my favorite place because I'm a recovering eclipse addict. I've traveled around the world and seen 9 total solar eclipses. I will attempt to see a 10th in March of next year.
Nice. So the question is this: does the moon rotate?
Yes, indeed. The moon rotates on its axis in relation to the stars, but it also takes about the same amount of time to revolve once around the Earth. And so it keeps the same geographic face, if you will, pointed inwards towards the Earth. So we only see the man on the moon's face, you know, from the vantage point of the Earth, right? Whereas you never see the far side of the moon from the vantage point of the Earth. Within certain limitations of the fact that the moon does wobble a little bit. They call it libration, and because its orbit is tilted, so sometimes people can see just above the North Pole, or just below the South Pole, or just around the left or east or west limb, so to speak. But you don't see the far side.
The dark side of the moon.
Well, it can be dark. It's dark when the moon is full. The moon is full. The side facing us is all lit, right? The side away from us is dark, right?
So if the
when
moon
the moon is new, such as during a total solar eclipse, then the side facing us is night. That's the dark side, right? Whereas the far side is all lit, right?
So if the moon did not
there is a
rotate,
far side of the moon, but it's not always dark. It's a disappointment.
If the moon did not rotate, would we see the far side?
Yeah, if the moon did not rotate
Yes.
in relation to the stars, you mean?
yeah.
Yes.
Well, sure, it would go around the Earth,
Yeah.
right? So you would get to see, it'd be like, you know, people doing that
Yes.
do-si-do kind
Yep.
of thing.
Yeah.
Is that what they call it? I don't know. I don't know my
So the background on this,
But yeah, there is a reason for this
my
question.
parents contest that the moon does not rotate, and we have tried every which way to convince them, no, it
Well,
does rotate.
again, remember, it's rotating on its axis
Yes.
the same amount of time as it takes to revolve around the Earth.
Yes, that's the exact thing I've been trying to explain.
We tried that. We tried everything. So we figured we'd speak to someone who knows, so we could convey the message.
It does indeed rotate, and now the reason that it is tidally locked to the Earth, though, that's not a coincidence. It wasn't always the case. If you go back 700 million years, right, to the Precambrian, the moon was rotating faster on its axis, and we would have seen the far side of the moon on occasion.
Okay.
You know, quite frequently. The moon was also closer to the Earth at that time as well, but the interaction, tidal forces interacting, slowed the moon down and locked it into that configuration. And now the moon is doing the same thing to the Earth, slowing the Earth down. The day on the Earth back in the Precambrian was probably 14 hours long. Now it's 24 hours long. So the Earth is slowing down, right? As a consequence, though, the moon moves further away, or the Earth and the moon separate more, I should say. So there's a conservation of angular momentum that has to be satisfied. But in about 2 billion years, the moon will be half again further away, but then both the moon and the Earth will be tightly locked together. And then only one side of the Earth will see the moon, just as only one side of the moon now sees the Earth. So that's 2 billion years, though, plenty of romantic moments.
Thank you very much, Matt.
Thank you.